Hey guys, this is Dr. L here, and we're going to talk a little bit about some fundamentals of toxicology, specifically the areas of exposure, dose response, and then like terminology that goes around all of this. So we're working our way over towards putting some numbers to toxins and to their effects. Most of the images and a lot of the content for this are taken from the Toxicology Mentoring and Skills Development Training resources that the University of California at Davis puts out, and the website to that is linked here. Toxicology can be defined as the study of the adverse effects of chemical, physical, or biological agents on living organisms in the ecosystem, including the prevention and amelioration of such adverse effects. Let's define a couple of those terms. Amelioration, this term here, means to make something better or to mitigate it. So it's to reduce harm. Adverse means something negative. So an adverse effect from a toxicology point of view would be harm or death, right? So harm would be morbidity when you lose health, and then death would be mortality when you lose life, right? So adverse effects in the world of toxicology could be morbidity or mortality. In this course, which is focused on poisons or toxins, and we're going to use those two words interchangeably, we're focusing on adverse effects from chemical agents. This is an old science, so people have recognized for a very, very long time that certain chemicals will have certain health effects, and that some of those health effects are negatives. In other words, poisonings occur. So back in the 1500s, Paracelsus, a famous philosopher, wrote in Greek, excuse me, and so the translations vary. All substances are poisons. There is none which is not a poison. The right dose differentiates a poison and a remedy. So in other words, the dose of something determines the poison. How much of it you are exposed to determines the level of negative effect. And this is the idea of dose and response. And we still use this idea today. Here's a term for you, xenobiotic. Xeno means foreign. So a xenobiotic is a term used for a drug that is foreign to the body. And that could be something beneficial, like using an aspirin to cure a headache, or it could be something harmful. It just means introducing some foreign chemical to the body. Often, it's the amount of whatever you're introducing that determines if the chemical is helpful or therapeutic. Therapeutic means helpful here, or a poison/toxin. So here are some examples of various chemicals. Some of them are therapeutic drugs. So at the bottom of the list, we have secobarbital, which is a sleep pill, aspirin, and ibuprofen. And we take aspirin and ibuprofen to combat headaches, fever symptoms, aches and pains, etc. So these bottom three things are therapeutic drugs. There are beneficial doses of them. So for the sleep aid, it's 0.1 milligrams per deciliter. It's 0.65 grams total for an adult for aspirin, or 400 milligrams for ibuprofen, 2 tablets. And all of those are non-toxic or beneficial doses. Alcohol, which is taken recreationally, can induce a euphoria feelings of well-being. There's some problems with that, but we won't get into them here. So at 0.05%, which is 0.05, you could calculate that in a variety of ways, but percents when you're looking at water-based solutions, a milliliter is a gram. So this would be 0.05 grams or 0.05 milliliters in 100 milliliters of the body, okay? If you treated the body as a volumetric flask. Carbon monoxide, which is a gas released from incomplete combustion, less than 10% of it in the atmosphere is non-toxic. But once we get up into these higher concentrations, we get toxic doses where we have adverse effects. And then we can get all the way up to lethal doses, right? So if we have more than 60% carbon monoxide in the air that we're breathing, then that will definitely kill us. And that can actually happen really quickly. Alcohol at 0.5% can kill you. You can die from alcohol intoxication. Sleep aids can kill you. Aspirin and ibuprofen can kill you at these really high doses. So these would be really high doses, but they would be toxic. Exposure means contact with a foreign substance, usually by inhalation, ingestion, or skin contact, although sometimes this could also be by injection, okay? Exposure assessment means the analysis or estimation of the intensity, frequency, and duration of human exposures to an agent. And here we're interested in chemical agents. So exposure assessments are something that industrial hygienists do, for example, in workplace settings. Exposure dose means the amount of a substance in the environment to which a person is subjected. Like, what does the person actually experience of those chemicals in the environment? And that's where we get into the term dose. And we're going to define that a little bit more in a moment. There are units for measuring the level of chemical that you are exposed to or that you are dosed with, okay? Usually exposure is given as a concentration, usually, but not always, okay? So a concentration means you have some amount of chemical divided by whatever the chemical is in. So maybe you're drinking a poison and you're drinking some amount of the chemical and we measure it in milligrams, which is a mass unit. And to make that a concentration, we would divide that by a denominator that is a volumetric measurement, say liters. So a milligram per liter is a concentration. If it was just a milligram, it would be a mass or total amount. Okay. So down here we see some metric conversions. So these are some common metric units for masses. So the base unit is a gram. If you have 1,000 grams or 1,000 milligrams equals 1 gram, 1,000 grams equals 1 kilograms, 1,000 micrograms equals a milligram, 1,000,000 micrograms equals a gram, and so on. And a single grain of salt is about a milligram. Volume might show up in units like liters or in length units that are cubed, right? So here we have a liter is the base unit in the metric system for volume. So this would be commonly seen in the denominator for a measurement of concentration. For context, you know about gallons because we use gallons to put gas in our car. So there are about just a little bit less than 4 liters in a single gallon. Okay, and 1,000 liters makes up 1 cubic meter. So a meter raised to the cube. Meter is a length unit, but if you cube a length, you get a volume. You might also see as a concentration a unit like milligrams per kilogram, where the numerator is a mass unit, but the denominator is also a mass unit. So a kilogram is also mass. This is often used when we're talking about absorbed doses of chemicals, okay? And here, while milligram would be the total amount or mass of the toxin, the denominator, also given as a mass here, would be a unit of the body weight. So this would be like, if you had 10 milligrams per kilogram body weight, it would mean you had 10 milligrams of the chemical for every 1 kilogram of your body weight. So that's a really useful and common way to measure dose or the amount of absorbed chemical in a body. I mentioned this before, but I just want to state it again because it's often a point of confusion. Volumes can be measured in dedicated volume units or by using length units and cubing them. So 1 liter is 0.001 meter cubed. 1,000 liters is 1 cubic meter. Okay, and that's we see cubic meters a lot when we're measuring gases. So it's which is really common in occupational settings. You might also see concentrations expressed not as units of mass per unit of volume or per unit of mass, but in units that are called parts per million, ppm, or parts per billion, ppb, or parts per trillion, ppt. And that's also really common in a number of settings, right? And so if these are aqueous solutions, we could say that a part per million is 1 milligram in 1 liter, a part per billion is 1 microgram in 1 liter, and a part per trillion is 1 nanogram per liter. And if you work in the area of industrial hygiene or a number of other disciplines, you will have to get pretty good at converting back and forth from parts per million to metric units. If you want some more information on that, there's a couple of linked resources. I will post this slideshow in the course area. This is a helpful thing for visualizing what parts per million is, but it means basically 1 part of whatever you're interested in within every million parts of whatever it's contained within. And this is a nice resource that I will also post for you that shows how you can interconvert between some of these units. So we regulate exposures by regulating the amount of chemical in a given environment. And an example of a regulatory limit that is seen in occupational safety is something called a PEL, or a permissible exposure limit. Permissible exposure limits are how long a worker, or any other person, can be exposed to a particular chemical over a particular length of time. Often that is an 8-hour shift, and so the permissible exposure limit will be derived from calculating an 8-hour time-weighted average. And these will vary in different settings. So the source of this is a paper by Sy, published in 2023. That link is in the notes for this slideshow, which will be posted. These are toxic volatile organic compounds, or VOCs, and these are just a handful of them. So for example, acrylamide is toxic. In Taiwan, the PEL is 0.03 milligrams per meter cubed, and this is based on inhalation as the route of exposure, and that's the same in the US. Whereas for the chemical acrolein, the PEL is given in parts per million, and it is less in Taiwan than it is in the United States. So these are set by government agencies based on data from a lot of research. All right, next we're going to define dose, but I'm going to do that in the next video.